Hello, today you guys will be learning 8.1 Introduction to Quadratics. Your learning target is I can identify key features of the graph of the quadratic function. So guys, this is very related to chapter 7, although we start out with graphing, which will feel a little bit different. We have already talked about standard form of a quadratic equation. This is y equals ax squared plus bx plus c. These look like our quadratic polynomials, trinomials specifically, that we were factoring before spring break. We also talked about a, b, and c and how we needed this to be in standard form quite a while ago, okay? So we have to graph these now. Believe it or not, you can actually graph them. When graphed, a quadratic equation creates a U-shaped curve that is called a parabola. So we're first going to go through the different types of parabolas. So if you want to, you can pull up Desmos graphing calculator and you can actually sketch these. Let me pull that up really quick. Have a little definition for that. So the vertical line that divides the parabola into two equal parts. Parabolas are symmetrical, okay? That's why it's called an axis of symmetry. So we have a formula for the axis of symmetry. This formula is x equals negative b over 2a. Okay? This gives you the equation of a vertical line. So the axis of symmetry for our parabolas will always be a vertical line. And we find it by using A and B from our standard form formula. Okay, we have another definition. The vertex. This is the turning point of the parabola. Okay, it's where it changes directions. We actually already saw this one too on our pictures above. I called them the maximum and the minimum point. So when the vertex is the lowest point, it is called the minimum. I usually shorten that to min. You can write the whole thing if you want. And if the vertex is the highest point, it is called the maximum or the max. Okay, so we're going to go through and we're going to find the axis of symmetry and the vertex, and then we're going to sketch it, okay? It's not going to look beautiful. I'm not going to use the Desmos anymore. We're just going to go through it as is, okay? So the equation for my axis of symmetry is x equals negative b over 2a. So if I need to solve for my axis of symmetry, A, B, and C are. We're going to, in this chapter, write out a ton of times what A equals, what B equals, what C equals. This problem, since it doesn't look like it's anything, is 1. Reminder, if you have a variable and there's no number in front, it's technically a 1. B is 8 and C is 15. They just go in order this way if it is in standard form. If it's not in standard form, you need to put it in standard form so that way you can figure out what A, B, and C are. Okay, so now that I have my formula written out, A, B, and C, so x equals negative b, so negative 8 over 2 times 1. Here, see that I put these. So I put the b in parentheses, I put a in parentheses. I don't, okay. I go ahead, I do this multiplication, I end up with negative 8 over 2, which means my axis of symmetry is at x equals negative 4. Reminder, this is a vertical line. Original I need to plug in this now. symmetry, your or down, okay? Figure out how to pick more points to graph, like 5, and not just this one. This is a very intro lesson, okay? Now, remember, if it was positive, it opens up like a approximated, not perfect, opening up through its vertex around its axis of symmetry. Okay, I'm going to draw in a little pro tip down here. If you are plugging in, put the number in parentheses. If it was already in the parentheses. Okay, that'll just help you with solving, plugging into the calculator, and all of that. Me, make sure that's all written out. Okay, question 2. Same stuff, we use our formula. X equals negative b over 2a, that is the axis of symmetry. We have to figure out what a, b, and c are. So a is negative 1, b is 10, c is negative 23. Before I even go any further, I'm going to look at this guy. I see that it's negative, so I know it's going to open down. It's a sad face. So I at least have that going for me. Okay, now I'm going to plug in my information. I've already figured out A, B, and C. So A and B are all I'm using right now. Eventually we will use C, but not in these problems. So I'm going to plug in negative 1 and 10 to this formula. You can do the erase and replace method if you want. Sometimes I do that. So like I need to replace B with 10 and I need to replace A with negative 1. Eventually, it's your goal to become so good at these that you don't need to do that erase and replace method. But if you need to, that's totally fine. We get our answer, x equals 5. So that is a vertical line at 5. Okay, for the vertex, if you have a calculator handy, this should be really simple. You just rewrite your equation, but you plug in 5 for x. Reminder, see how this negative, guys, was part of the original problem? That's what I mean about keeping it outside of the parentheses. Okay, that'll change your answer if you put it on the inside. So really pay attention to that. And then finish it out. Plus 10 times 5 minus 23. So this gives us negative 25. plus 50 minus 23, which means that y is equal to 2. Once again, you could just use your calculator. These two work together to create the vertex point 5, 2. So we'll sketch our graph. We just need to know these three things about it. That our vertex is right here. We have our axis of symmetry through that point at x equals 5, and that it opens down. All right, we're going to skip ahead to 4. Go ahead and pause me. See if you guys can do this one on your own. All right, question 4. You have your axis of symmetry equation, x equals negative b over 2a. We decide that a, b, and c are a is 4, b is 8, c is negative 1. We go ahead and we plug this information in. So my axis of symmetry equation, I have x equals negative b over 2a, which means when I solve, I get negative 1. So x is negative 1. I take what I found there and I plug this into my original equation that is found up here. Y equals 4x squared plus 8x minus 1. So I replace the x's with negative 1 in parentheses. So that way if I plug it into my calculator, I know I'm good. Actually, that will be minus 8 minus 1. I did this in multiple steps here because our a value is 4 this time. And in the past, it was just like a negative. But we finished solving, and I believe we get negative 5 for y. Now, a reminder, x and y work together. So it's not just the y is your answer. You have negative 1, negative 5. And we sketch our graph. So we're doing good. We've got our vertex, which is at negative 1, negative 5, 3, 4, 5. We have our axis of symmetry, which is at negative 1. We did not discuss yet. A is positive, so this opens up. It's like a smiley face. So that is what your parabola looks like. Now, we haven't really talked about either maxes versus minimums, because this is considered a minimum because it is the lowest point on the graph. Okay. Question 2, this would be considered a maximum because it is the highest point on the graph. All right, let's go ahead. If you need to pause to write all that down, go for it. I'm going to continue to 7. So this one is a little bit weird. Don't freak out about it. Same equation for axis of symmetry, negative b over 2a. We do have an a value. It's negative 1. We do have a b value. It is 4. Our c value this time, since there is no number, is 0. That's okay. We don't actually even use c for this. And before we move on, I'm going to say since a is negative, this is going to open down. Okay? So you can tell all of that stuff just from the a, b, and c, and then you use your formulas to finish solving. So we have negative b over 2a. I plugged in my information. This gives me negative 4 over negative 2, or x equals 2. Then, guys, this second thing for the vertex always changes. It's always the equation that you are using. So we have y equals negative, and then using the 2 that we just solved for x. Plug in that info. We then have negative 4 plus 8. and y is then equal to 4. So our vertex is 2, 4. We can sketch ourselves a little graph here. Let me make it bigger. So we have our vertex point, always graph that first, over 2, up 4. We have our axis of symmetry, which is a vertical line through that point. And we know this opens down. Okay, this also means that this is a maximum. It is the highest point on the graph. All right, pause me. Try question 8. All right, question 8. Same axis of symmetry equation. Notice it does not change. It's always negative b over 2a. This time a is 1 because there's no number in front of x squared. It is 1. B is actually 0 because there is no x term at all, okay? There's no x term making B 0, and C is negative 3. Guys, the difference between having a 1 and a 0 is the fact that this variable does exist, okay? So we're going to go ahead and plug this information in. This tells us that x equals negative 0 over 2 times 1, making x simply equals 0. Okay? So this is kind of nice. These are going to be an easier problem because, first of all, we don't have a b. And second of all, we are plugging 0 in for x squared. So it's fairly quick to solve and get that y is negative 3. Reminder, x and y work together to make the vertex 0, negative 3. So we'll go ahead and graph this. We go over 0, down 3. That is going to be our either a maximum or minimum point. We don't know yet. Because our graph has a positive a value, this will open up like a smiley face. It's positive, so opens up. So we're going to go like this, making this vertex point a minimum. All right. With any extra time, you can do more examples either in the notes or on the next page in your packet. It is titled Homework 1, Introduction to Quadratics. You could work through those as well. Both of these have keys on Classroom. Make sure that you're really understanding this because we're moving into this sort of graphing of quadratics realm. Okay? Have a great day. Stay diligent. Work on your things. I'll see you later.